and we understand that for many of you this is a review, is because there's still a major pain point, and BMW AG has acknowledged that our clients are still offering feedback about the fact that when they go into a BMW retailer and they have questions about EVs, not only about our product, but about the EV lifestyle and the changes they may need to make to their driving habits, we don't necessarily have the answers ready for them. And of course, in the worst case scenarios, which we want to avoid at all costs, we provide misinformation or, at worst, incomplete information. So for example, there's a story that Dean and I have heard about a client in a Middle Eastern country who asked their product advisor about buying an iX. They were told that this particular iX had a range of 450 kilometers, end of story. The client bought the vehicle, got out onto the highway, set the cruise control to 170, and was very upset when they only managed to run about 200, 225 kilometers before they were completely out of power and at the side of the road. Now, this wasn't the fault of the vehicle, right? Right? What do you think happened?
The usage.
Right. Because driving an electric vehicle in a straight line at highway speeds provides no opportunity for recuperation. So that client needed to have been told by their sales advisor about when an EV is at its most efficient. And we'll find that it's mostly in city driving, where the stopping can actually build power back up into the battery system. And furthermore, cruising at 160 or 170 is not an efficient way of driving any vehicle, even if it's a gas-powered vehicle.
What about temperature in the car? I mean, the Middle East, that's gonna...
Right, it's gonna be hot. You're probably having your air conditioning running all of the time, right? And that's going to put an additional drain on your high voltage battery to run those air conditioning systems. When we talk about level 1 charging, as you know, we're referring to what you can get out of your home power outlet, out of 120 volts. And this is sort of our North American standard. And if we use this i7 xDrive 60 as an example, we are likely not going to be able to advise our clients that it makes sense for them to buy this vehicle if they only have the opportunity to charge it at level 1, because it'll take that long. Who has 4 days to wait to charge up their car? No. And keep in mind that when you're charging at 1.2 kilowatts, which is the amount of power you're typically getting out of your 120 volt socket, that's the equivalent power to your hair dryer or your microwave, right? It's not going to be enough to recharge this high voltage battery in any, let's say, usable amount of time. Some would say that when you get a flex charger with the vehicle, or what we used to carry, the occasional use cables that only operated at 120 volts, those were for emergencies only. If you know you're going up to your friend's cottage or your own cottage and you have 3 days to park your car, bring that. But there's a reason why we're including or offering flexible fast chargers in our vehicles. And that is because it drastically cuts down the amount of time it takes to charge that vehicle. Level 2, now we're running 6 microwaves at the same time, give or take. Right? We're bringing a lot more power into the vehicle to charge it up in a usable overnight amount of time. Right? And of course, that is based on numerous things, including the power grid in the customer's home. We have to discuss with the client, do you have the capability of hooking up a 240 volt outlet so that you can run your flexible fast charger at its highest capacity? Or do you have the ability to install a wall box? And I'll speak a little bit later on as to how we can help them with that, right? We're not just going to sell them the car, we're going to sell them the service, the vehicle, and a way for them to get that installation complete, to have their high voltage set up at home before their vehicle is delivered to them. And of course, DC fast charging allows us to put the maximum amount of current back into the battery in the shortest possible amount of time. The tricky part is, you can't do that at home. If you were to go to some of the most modern high voltage DC charging stations that are out there, some of them are capable of pushing out 300, 400 kilowatts. So 300 microwaves running at the same time, 300 hair dryers running at the same time. If you did that at home, you're going to cause a brownout in your neighborhood, right? And that's assuming that the wiring in your home doesn't melt first, because our homes are not designed to carry this much current through it. Now, when we speak about charging at home, as mentioned, we're using our flexible fast charger, whether we're at level 1 or level 2. The advantages of our fast charger. 1, it's included with the car. It's portable. If you're going to an Airbnb, going to your chalet, pick it up, throw it in the trunk, take it with you. That way you always have something there that you can use to charge your vehicle when you need to. It comes with an 18-foot cable, which for most people is going to be fine. Some people have very long driveways, very large garages. It might not be enough. And we also understand that the flexible fast charger, though usable, is not very elegant, right? It's this big blocky thing that you take out of your trunk if you haven't installed it at home, or you have to find a way to mount it to your wall. And it looks like something you've added on to your home. The wall box offers a slightly more elegant solution. The flexible fast charger and the wall box will charge at the same rate if they're plugged into the same 240 volt circuit. The main advantages of the wall box are that it is prettier to look at, right? And that's a distinct advantage. It looks a little bit more purpose-built, and it comes with a 25-foot cable as opposed to an 18-foot cable, meaning that you have just that extra little bit of reach so that you can get to your car if it's parked a little bit further away from the power source, right? And that can be an advantage for some people who have multiple cars in their garage, very large driveways, for example. You cannot use extension cords with vehicle chargers. Make that a rule. If anyone ever asks you, can I plug in my flexible fast charger into an extension cord and then plug that into my house? No, don't do it, okay?
Not even with hybrid cars, like level 1?
As a general rule, no. In an emergency, do what you want, but anytime you introduce another length of cable, you're increasing the resistance across, and you can end up creating some excess heat, and a further point where those two connect, water could get in, snow could get in. And that's not to say you can't charge your electric vehicle outside in the rain or the snow, you can. But you don't want to have open extension cords or areas where water can get in outside. The plug that goes into the vehicle is protected, right? So that's okay. Public charging level 2, so the charge point, for example, charge hub, these are great for on the go, but because they are level 2, at most, you'll be getting between 7.4 kilowatts to 9.6 kilowatts at these public chargers. It's good for a top-up if you have an hour or 2 hours at your destination to wait. If you really need to build up some travel in your vehicle, that's when you really want to be using level 3. And again, these are pay-per-use services for most of our clients at level 3 public chargers, but they are quick. There are still some drawbacks to them, such as how many other people may be using them when you get there. And they do not all put out the 195 kilowatts that an i7 can accept. Many of them are 50 to 100, maybe 150 kilowatts at most. Any questions about that? Awesome.
Yes, sir.
Yeah.
Go right ahead.
Some public chargers near our dealership go up to like 220, 230.
Okay.
The i7 can't accept that, can it? It's just like max 195.
Correct.
Okay.
And I think Dean will talk a little bit more about that max 195, because again, if we're going to be explaining the theory of how our vehicles charge to our clients, yes, the i7 can accept 195 kilowatts. But the question I'll ask you, and then let Dean talk to, is it going to bring in 195 kilowatts for the entire duration of its charge?
Perfect. Okay guys, so the number one influence on our batteries is temperature. And you've probably heard myself or Brian talk about this a few times. So whether it's too cold or too warm, it really doesn't make a difference. So let's talk about where temperature influences come from. So you've got an electric vehicle, you're driving down the road and you put your foot down on it. As those electrons move from the battery through the electric motor, we generate a lot of heat. So that's why boost functions only last for a few seconds, because there's a great deal of heat and everything needs to cool down again. So let's start off talking about a cold weather situation. And we're going to talk primarily about a battery electric vehicle, and then I'll talk a little bit about hybrids. So since generation 4.5, which was the Mini SE, do you guys know which the Mini SE was? Yeah? Fantastic. So the Mini SE was a little bit of a groundbreaker. It was the first electric vehicle in the BMW lineup to come out with a cool and cooled battery. And now we're running generation 5. So all our battery electric vehicles are cool and cooled. So if we have a cold weather scenario, it's -40, it's Canada, this is normal here. Well, that battery is not going to want to work. It's like, I want to stay under the blankets, it's freezing cold, I really don't want to do any work today. But you know what, we're going to provide you a hot water bottle and we're going to warm you up and get you in the right mood so you can actually go to work. And that's essentially what we do. We pump warm coolant through the battery and bring those temperature of the battery cells up into what I like to call the Goldilocks zone. I have a slide on it, I'll show you what that is in a minute, but we need to get the battery into the right operating temperature. And the reason we want it in the right operating temperature is twofold. Number one, we're gonna get the best performance out of our electric vehicles. We're also gonna get the longevity out of these batteries, so that's very important. Now let's jump to a hot weather climate. So it's a beautiful summer day here, it's 28, 29 degrees. You get in your vehicle, and now the battery is actually warm because it's ambient temperature. It's way outside of its Goldilocks zone, or just above anyway. But once you start driving the vehicle and those electrons start moving, it certainly will move out of that temperature zone. So how do we cool that battery? Well, the same way as we heat it up. Everybody's been to 7-Eleven, and when you go in 7-Eleven, I always see those slushy machines with like the ice and everything that's going through. Imagine like one of those slushy machines is pumping liquid coolant all the way through your battery, bringing down the temperature of those battery cells. And we're going to get it into the Goldilocks zone. So let's talk about a little bit about charging and how charging can affect temperature as well. So essentially, when we're charging up a vehicle on a level 1 charger, it's a really slow trickle charge. And I like to use this analogy. Imagine there's a movie theater, it has 1,000 seats. Now, the first 800 patrons get to go to the movie theater and they can jump in and get all the seats because there's very easy seating assigned. But now the last 200 patrons. Now there's a seat over here, there's one over here. Well, this one's easy, but if I've got to go to that seat in the back, I've got to climb all over you guys and get there. So it's going to take me a lot longer. And this is the 20 to 80% charging rule. I'm going to drill down that in a second. Now, when we charge up our electric vehicles, the faster we charge the electric vehicles, the more heat that we generate in our batteries. So as we're charging it, we're generating heat within the batteries, but we're going to use some of that energy through our heat pump, which is a series of mechanical and electrical devices that are designed to either cool down the battery or heat up the battery. In this case, we're going to cool down the battery. So the heat pump's going to kick in and it's going to cool down the battery. This ties into preconditioning, which Brian's got a little bit of information. So when you precondition your vehicle, and I'm not talking about the interior cabin preconditioning, I'm talking about entering information and navigation. As you approach that charging station, the battery starts to cool it, knowing that it's going to take a charge. So very, very important. Now, let's just talk about the 20 to 80% here. So there's a bit of misconception. So let me ask you this. If I'm using a level 2 charger, is there any problems charging up to 100% using a level 2 charger at home? What are your thoughts? It's okay. It's totally and utterly fine. You know, the rate that the electrons are flowing into the battery doesn't create that much heat. And there's a lot of sophisticated electronics that's going to help balance everything out. But if I'm going to do a long distance drive, I am certainly going to make sure my electric vehicle is topped up to 100% on a level 2 charger before I start my drive. So with a level 2 charger, as Brian said, it's 9.6 kilowatts of energy. It's a lot of energy going into the battery. It generates a reasonable amount of heat, but it's easy to manage. Now, let's say we go to a DC charging station. This is the rule I like to use with DC charging stations. Because when you charge DC, you don't have to go through like any voltage rectification inversion process or anything like that. It's basically a DC hookup and you're going to be able to charge that battery up very quick. Now, imagine those 800 people rushing into the movie theater and they're all bumping into each other in the corridor. Well, that's like electrons in the battery. It creates a lot of friction, creates a lot of heat. So when we DC charging, we do generate the most heat in our charging process. And this is why it's super important to precondition and enter your destination in navigation. And this is the main reason why we only charge to 80% because of the amount of heat. Now, as a general rule of thumb, it's going to take you just as long to charge from around 20 to 80% of one of our electric batteries as it will do from 80 to 100%. Does that make sense to everybody? And that's because of that same analogy I used about the movie theater. Oh, there's a seat over here, there's a seat over there. It takes a lot longer to put those electrons where they need to be. Now, without getting too deep into the weeds, it's a common misconception. When you plug in your electric vehicle, the electricity isn't going from the wall straight into the battery. The actual electricity is being there to do a job. Essentially, when a battery's empty, all the electrons are on one side of the battery, or rather they're actually equal, to be honest with you. And what we need to do is we need to take the electrons and we need to put them back on the positive side, so we have something basically where we have what's called a potential difference. So when we charge the vehicle, the electricity from the wall doesn't actually fill up the battery. It has a job. It takes the electrons from the negative side of the battery and escorts them over to the positive side of the battery. That's what we're doing when we're charging. We're taking the electrons from one side of the battery to the other side of the battery. And as we do that, through that chemical process, it basically generates heat. So here's another source of heat, and that's why we have to control the charging process. Let's go to the next slide here. Now, this might be on the little quiz that we've got coming up, so it's an important number. I like to call this the Goldilocks zone, and the Goldilocks zone for our batteries is between 25 and 40 degrees. The electronics in our vehicles is going to do what it can to maintain this temperature at all times in the battery. There's two reasons. Remember I gave you them earlier? Performance and longevity. Very, very important. Now, let me ask you this. What's the warranty on our electric vehicles?
8 years.
8160? Yeah, fantastic. Is that peace of mind?
On the battery.
Yep.
On the battery and associated.
Yeah. Is that good peace of mind though? No?
Well, knowing the price of the battery afterwards.
Are you going to keep an electric car for 10 years after all the technology's changed so much? Probably not. I mean, if you look at battery technology, it's advancing at a very, very, very quick rate. There's all sorts of new things. There's graphene, there's all sorts of new technologies coming. We're using lithium-ion batteries. Probably we won't in about 3 or 4 years because of the sustainability for them. We probably, in a couple of years, is going to be using hydrogen fuel cells in order to power electric motors. So then your customer who's got an older vehicle with that older technology is probably going to trade it in and move to the new technology. So as a general statement, I think 8 years, 160,000 kilometers is a lot of peace of mind for any customer that's buying an electric vehicle, because chances are they probably won't see that vehicle to the end of their lifestyle, and most of our customers lease them anyway. So, very, very important guys, 25 to 40 degrees, lots of electronics to maintain that temperature, and we use what's called the heat pump in order to do that. It's either going to heat up the battery or cool the battery down to get it in there. I want to talk to you about the charging menus, and I touched base on this a little bit earlier today. This is very important. You guys are all customer facing. It would be embarrassing when you do a demonstration of a vehicle and a customer, hey, you know what, I'm having an issue with my particular vehicle, how do I do it? I don't know, and you're fumbling around. Well, I'm going to single out the service advisors on this one, because here's a really good scenario. We've sold an XM to a customer. Salesperson draws a blank. Uh-oh. Could have been answered at the sales desk. Could have been, hey, this is normal operation. Or you can change something, and I'll tell you what I want to change in a minute. But in this case, the salesperson's failed. So now the car is being escalated into the service department. So now it goes to the service department, and the customer's complaint is, at night, I cannot sleep because the car is making so much noise from the electric fan. What can we do to appease the customer? Should we book it into service, maybe have a technician look at it? How could we help the customer? What are your thoughts?
Schedule charging times?
Schedule time, you're almost there.
Change the settings in here, in the iGraph system.
Okay, but what setting exactly?
Fan loudness.
Fan loudness, right there, right in front of you. Who knew there was a fan loudness setting? Just a couple of you guys. Okay, so perfect. So on our vehicles, there is a fan loudness setting. And when you put this vehicle on charge, the level 2 charger in your home, obviously the battery's going to generate heat, right? Because it's charging. So what do? We need to cool down everything. So just like a regular vehicle on a hot summer's day, we have overrun fans. So when you get, everybody's experienced this, you get out of the vehicle on a hot summer's day, the fan runs for a couple more minutes to circulate the coolant and continue on. Well, this is very, very similar here, but you have the ability to control the fan loudness settings. So let's say the customer lives in a paper-thin house, they're complaining about this. As a salesperson, we should have been able to handle it. Say, no problem, completely understand. What you need to do is go into your iDrive menu, you need to go into the OS8 operating, go to fan loudness, and then actually just turn that down. Now, there is going to be an effect once you turn it down from the highest setting to the lowest setting. What do you think the effect on the charging is going to be?
Charging slower.
It's going to charge slower, right? So it's a little bit of a balancing act, right? We have to tailor all of this to our customers. So, I I gave you a really good analogy. From a salesperson, you're going to be the first person that they call if there's an issue with electrification. It'd be very good for you guys to understand and manage those calls. Then it goes to a service advisor. Now, as a service advisor, if you hadn't come on training, you may have thought, oh, this is obviously an issue with the car. Now the car goes into the service. I'm going to call out a technician in the room, Ryan. It's going to go into service with a noisy fan, and you're going to test it. And what are you going to say? No fault found. The 3 most deadly letters in the English alphabet. NFF. Not very good, right? So we don't want that to happen. So there's loads of opportunities for you in sales, for service advisors, product geniuses, for you to de-escalate customers' complaint by knowing your product. Lots of different settings in here. We can precondition the battery. We can set the charge rate, so you can change the amperage. Let's say you have a customer in an older house. Okay, so you can go into the settings. Maybe they've not had an electrical inspection, but they want to do a level 1 charge. Customer notices, oh, that plug's getting a little bit warm, but you've got the amperage setting on maximum. How about going into the iDrive setting and turning down to 6 amps or something like that? So it's not going to draw as much power. It's going to protect the infrastructure of the homeowner. What's the effect on the customer's charge time? It's going to be a bit longer, isn't it? So everything is a bit of a balancing act. Brian, back to you, sir.
Thanks. Now, just to use this slide for 1 minute before I keep going, we're going to talk briefly about preconditioning the battery. Dean touched on it at the beginning of his talk. Preconditioning the vehicle for comfort is one thing. That's where we can activate the climate control ahead of time, and the car will be air conditioned or heated when I get into the car and I'm comfortable as the driver or the passenger. But Dean also said that we have to precondition, or at least we have the option to and should precondition our batteries. If we have plugged in our vehicle and we have told the vehicle that we are going to be leaving at 8 o'clock in the morning, not only is it going to precondition the passenger compartment and get it comfortable for me, but it is going to use the power from the grid, because it's still plugged into the charger, to start the process of warming or cooling our high voltage battery. Meaning that as soon as we drive off, it is at its optimal temperature to start giving the electrons to the motor to get us moving. If we read what it says here in the precondition menu, it'll allow for quicker charging at low or high temperatures, and one of the options is to have it activated automatically if route guidance to a DC charging facility is active. So what does that mean? How many of you use Waze or Google Maps primarily to get around town? Right? A lot of us do. Why? Because the maps are pretty, because it tells us where the police officers and speed cameras are, right? We know that that's the majority of us. It's really handy to have. We can take our phone with us, we can program it into Waze, get into the car, and there it is on Android Auto or Apple CarPlay. The thing is, the BMW doesn't know where you're going if you're using Waze or Google Maps. If, however, you use the BMW built-in navigation system and set a destination as a high voltage charging facility, well, now the BMW knows, okay, I'm 15 kilometers from where I'm going to stop to charge. What will it start to do?
Preconditioning.
Right. It's going to start to precondition the battery before you ever get to the charging station. So as soon as you show up and you plug in that charger, there's no time being lost and no energy being wasted preconditioning the battery to take in the charge. It's all ready to go. So will it take you less time to charge the vehicle and get on your way? Yes. And if you're paying for that charging, will it be a little bit less expensive? Yeah, because more of that energy that you're taking is being used to move the electrons from the negative over to the positive side of our high voltage battery, rather than just to warm or cool it. And if you use your My BMW app to enter in that destination and then send the destination over to the car, which we can do, it works the same way. The My BMW app is the gateway to the majority of the BMW's advanced functions. This is why mapping and apping is such a priority, and why clients who, for whatever reason, choose not to use the BMW app are going to be at a disadvantage, especially when they start getting into our newest and most capable vehicles. And that's why we're pushing really hard to get them to use these services. You can of course use third-party apps provided by ChargePoint, Petro-Canada, Electrify Canada, any of these organizations that have their own network of chargers, or amalgamate the data from the different providers. But again, if you use that system to get to the destination, the battery doesn't know it's going to be charging soon. So find the address, use it to see if there's anyone at that charger, but then put the address into the BMW's iDrive or into the BMW navigation to get there. Just as a side note, there's one other advantage of using BMW navigation that we kind of forget about. If you were to drive through a tunnel in a mountain and you lose your GPS, when you lose your GPS, Waze and Google Maps, they stop working because they don't know where the car is. The BMW will use the wheel speed sensors to get an idea as to where it is on the map, even if it doesn't have the GPS signal. So it knows roughly where it is, and when you come out on the other side and it can pick up that satellite, it might make a small adjustment on the screen as to where it is in real time, but it has a pretty good idea already. So just a couple of little things to keep in mind. Of course, if we want to try and be efficient, and we talk about this frequently, that I just spoke to, doing your climatization at home while you're still plugged in means you're not taking battery power to warm up or cool down the passenger compartment. No, I must have lost something here.
Click failure.
Oh, absolutely. Or Brian failure. Oh, there's my cursor. And click that and I'll just go. So drive moderately. It's not to say you can't have fun with your electric vehicle, but we know that if we're going at 130, 140, 150, we're using up a lot more of our electricity than we are if we're traveling at 100 or 110. It's exponential in terms of how much power you use to get at those higher speeds. There's more rolling resistance, there's more air resistance acting on the car. Charge often. Again, there's no reason not to charge whenever you possibly can. The car will not allow you to damage it because it has circuitry built in to protect the battery. And yeah, take the efficient route when it's available, if it's fine, right? Again, have fun with your car. If you know you're going to be somewhere where you can charge the car at your destination, then maybe you don't have to abide by that rule as much, but it's always helpful. We just have a couple more things to talk about in this presentation. Then we're going to do our quiz. We do have an exciting prize for one of you. And then we've got a really cool presentation from Oscar and our after-sales team coming up at the very end. How many of you are familiar with Q-Merit? A little bit?